Have you ever wondered how AI systems make decisions? Or why some of their answers might change, even when the question stays the same? Today, we're diving into a groundbreaking idea that could change how artificial agents remember and reason, a concept called the Merkle Automaton. Let's start with a problem. Traditional AI, like the language models you've probably used, relies on complex statistical patterns. But here's the catch. These systems do remember how they arrived at an answer. Their memory is like a sandcastle prone to erosion. Over time, as they're retrained or updated, their beliefs can shift subtly, leading to inconsistencies. This is called epistemic drift, a fancy way of saying their knowledge becomes unreliable. So how do we fix this? The answer lies in blockchain, and a clever twist on old computing theory. Imagine an AI that doesn't just process information, but logs every step of its reasoning in a way that's permanent, tamper-proof, and verifiable. That's the Merkle Automaton. Think of it like a digital ledger for an AI's mind. Every decision, every transition between states, is recorded in a structure called a Merkle tree. These trees are like digital fingerprints. Each block of data is hashed and linked to the next, creating a chain. If someone tries to alter even a single detail, the entire chain breaks, making tampering obvious. And because these chains are anchored to a blockchain, the same tech behind Bitcoin, they're publicly verifiable and immutable. But how does this work in practice? Let's break it down. Traditional AI systems use neural networks that adjust their internal weights as they learn. This is great for flexibility, but terrible for accountability. The Merkle Automaton replaces this with a deterministic framework, like a step-by-step recipe. Each action the AI takes is cryptographically sealed, with a timestamp and a unique hash. These are stored in a blockchain, so anyone can audit the AI's entire thought process, from start to finish. Here's the kicker: this isn't just about security. It's about truth. By tying every decision to an unchangeable record, the Merkle Automaton ensures AI can't hallucinate or invent facts. If an answer lacks a verifiable trail, it's flagged as unreliable. It's like giving AI a digital fingerprint for every claim it makes. But the benefits go deeper. This system solves a big problem in AI: catastrophic forgetting. Traditional models forget old knowledge when learning new stuff, like a student who studies for one exam and then can't remember the previous material. The Merkle Automaton fixes this by storing every lesson as a permanent block in the blockchain. It's like a student who never forgets their old math, even as they learn calculus. And here's where it gets even cooler. The Merkle Automaton uses advanced cryptography to protect sensitive information while still letting others verify its authenticity. Imagine a secret diary that only you can read, but anyone can check if a particular entry exists in the book. By combining blockchain with encryption, the system ensures privacy without sacrificing transparency. So why does this matter? This isn't just about building smarter AI. It's about building trustworthy AI. By anchoring every decision, every answer, every memory to a tamper-proof record, we create systems that are auditable, accountable, and resistant to the hidden flaws of traditional models. Let's unpack how this works at the technical level. At its core, the Merkle Automaton leverages Merkle trees, a data structure where each leaf node is a hash of a data block, and each non-leaf node is a hash of its children. This creates a hierarchical, cryptographic summary of the entire dataset. When integrated with blockchain, the root hash of this tree becomes a permanent time-stamped record. But it's not just about storing hashes. The anchoring schema embeds this Merkle root into a blockchain transaction. This transaction includes a tag to mark it as a memory anchor, a timestamp or sequence number, the Merkle root itself, a signature from the data owner, and optional metadata. It's like a digital notary stamp, public, immutable, and verifiable. To check if a file is intact, you retrieve the blockchain transaction, verify the signature using the owner's public key, then recompute the Merkle root from the data fragments. If it matches the stored root, the data is valid. It's like checking a puzzle's pieces against the original image. And here's the cool part: this system isn't one-size-fits-all. You can tweak it. A minimal anchor stores just the root and timestamp, while a signed anchor adds accountability through cryptographic signatures. For privacy, encrypted anchors hide metadata, and batch anchors handle multiple datasets at once. It's like choosing the right tool for the job: performance, security, or flexibility. Now let's talk about controlling access to this data. Imagine the Merkle tree isn't just a static file, it's a dynamic web of knowledge fragments. To prevent unauthorized access, we use access-level policy graphs. Think of them as a hierarchy of security clearances. Each fragment of data is tagged with a level, and users must have the right clearance to access it. For example, a low-level fragment might be like a public document, while a high-level one is classified. The system ensures you can't traverse from a low to high level without proper authentication. This creates a secure, auditable framework where data integrity and confidentiality coexist. In essence, the Merkle Automaton redefines what it means for AI to remember. It transforms ephemeral computations into permanent, verifiable records, bridging the gap between machine learning's flexibility and the need for accountability. This isn't just a technical innovation, it's a philosophical shift, one that asks, how do we ensure AI systems are not just powerful but also transparent? The future of AI isn't just about what it can do. It's about how we can trust it to do it. And the Merkle Automaton is a critical step toward that future.